I'm creating this video for a student who is in a college class that is working with trigonometry now, and this student um, never had the advantage of having geometry um, in high school, so he missed out on the basics of trigonometry. So I'm reviewing it, I'm going to make it a public video, and hopefully it'll help some other people as well understand trigonometry just a little bit better. It's going to go into a little more detail than geometry, because trigonometry basically just covers the first quadrant, all acute angles, but we're going to go beyond that in this video. First of all, trigonometry, trigonometry. Metry is measure of. You're like a meter is a basic measure. Trigon is literally, it means triangle. So trigonometry really is the measuring triangles. Specifically, we're talking about right triangles when we're dealing with trigonometry. And there are three basic trigonometric ratios that we learn in geometry, and those are sine, cosine, and tangent. And we learn a little acronym to help us remember what sine, cosine, and tangent are. First of all, let's talk about the abbreviations of sine. The abbreviation for sine is SIN. It has nothing to do with sin, but it is kind of funny that it happens to be look like that. There's nothing sinful about sine. Cosine, the abbreviation of for cosine is COS, and the abbreviation for tangent is TAN. Basically just the first three letters of the words. Now, the definition of sine. The sign of what? Well, sines are ratios. Ratio is like a fraction. So what ratio gives us the sine? Well, we're talking about an angle, and this angle theta, that's the Greek letter theta. Theta has a sine, theta has a cosine, and theta has a tangent. Theta's sine is whatever the ratio of the length of the opposite leg divided by the length of the adjacent leg. That will be theta's sine. Opposite divided by adjacent. Theta's cosine will be whatever the adjacent leg's length is divided by the hypotenuse's length. Adjacent divided by hypotenuse. And the tangent will be opposite. The opposite leg length divided by the adjacent leg length. And adjacent, if you think of it, adjacent means next to or touching. So this angle theta is formed by the adjacent leg and the hypotenuse. Those are the two sides of the triangle that form angle theta. So it makes sense that the adjacent leg is the leg that helps to form the angle theta. Now, we have an acronym. And I was taught it in high school, some old horse came a-hopping through our alley. I've also heard some more risque, like some old hippie caught a high tripping on acid. Anyway, whatever you want to use to remember, and some people just remember SOHCAHTOA. Alright, now, there are tangent can also be defined by doing this. If we multiply by the reciprocal of the hypotenuse over the reciprocal of the hypotenuse, we get opposite over hypotenuse divided by adjacent over hypotenuse. Well, opposite over hypotenuse, that's sine. Adjacent over hypotenuse is the cosine. So there's a little algebraic manipulation to show you that really the tangent of an angle is just the sine of the angle divided by the cosine of the angle. Alright, now. So as an example, let's find the sine, the cosine, and the tangent of this angle theta right here. The sine of theta equals, well, first of all, you know what, we're going to need to find out what the length of this side right here is. How are we going to do that? We're going to use the Pythagorean theorem. X squared plus 5 squared equals 9 squared. I'm going to leave the a lot of the math to you guys. Um, you can pause the video and figure this out, but that's going to be 81 minus um, 25. So x squared will equal 81 minus 25, which is 56. And so x would equal the square root of 56. So that means that this guy is the square root of 56. So the sine of theta is the opposite, which side is the opposite side over here, 5, divided by the hypotenuse. Opposite over hypotenuse. That's 5/9. The cosine of theta, that's adjacent over the hypotenuse. That's the square root of 56 over 9. And the tangent of theta, that's the opposite over the adjacent. Opposite over the adjacent, that's going to be 5 over the square root of 56. And I'm going quickly because if you need to pause and digest this video, you can obviously just pause it anytime and digest what I'm saying. Now, there are some reciprocal ratios. The secant of theta. Secant is the reciprocal of secant is the reciprocal of cosine. 1 over the cosine. Since cosine is adjacent over hypotenuse, secant will be hypotenuse over adjacent. Cosecant is the reciprocal of sine. So since sine is opposite over hypotenuse, cosecant will be hypotenuse over opposite. And the cotangent, well, you probably guessed that cotangent is the reciprocal of tangent. Since tangent is opposite over adjacent, cotangent will be adjacent over opposite. So now, let's practice with these. Let's see, the sine of, well, and you can use Pythagorean theorem to find this missing side, but I'm going to save some time, and we would use Pythagorean theorem, x squared, 5 squared plus x squared equals 13 squared. We'll find out that this side is 12. And we're going to find out that this side here is using Pythagorean. Oh, wait a minute. My bad. Let me pause this for a second. Okay, and I designed it this way on purpose so I come up to whole numbers, just for simplicity's sake. The hypotenuse, with the hypotenuse 5 and this leg 3, the other leg will end up being 4, using the Pythagorean theorem. You can confirm that if you like. Now, this triangle here, the sine of theta will be, okay, well here's theta, look at theta, that's going to be opposite over hypotenuse. Well, opposite over hypotenuse, that's 5 over 13. The cosine of theta, there's theta, he's going to be the adjacent over the hypotenuse. 12/13. And you might want to pause the video and check yourself on these and see if you get them right. That'd be my suggestion. The tangent of theta is these opposite over adjacent. Opposite over adjacent. 5/12. Cosecant of theta. Remember, cosecant is the reciprocal of sine. You just have to memorize that. So the reciprocal of sine would be 13/5. And the secant is the reciprocal of the cosine, so that would be 13/12. And cotangent is the reciprocal of the tangent, so that would be 12/5. And you'll notice, sine and cosine, the opposite and the adjacent, those legs, they're never going to be as long as the hypotenuse. So they're always going to be less than 1 if the angle is acute. We'll learn that they can equal 1, but Sine and cosine are always less than 1 or equal. The reciprocals, therefore, will always be greater than or equal to 1. Secant and cosecant will always be greater than or equal to 1. And tangent and cotangent, they can take on any value. All right. Now, the sine of theta, sine, cosine, tangent of theta here. Okay, well, the sine of theta, remember, theta is up here now. So the opposite leg is down here, 3. So let's put that here. The sine is going to be opposite over hypotenuse, 3/5. Cosine will be adjacent over hypotenuse, 4. Tangent will be opposite over adjacent, 3/4. And the cosecant will be the reciprocal of sine. Secant will be the reciprocal of the cosine. And cotangent will be the reciprocal of the tangent. And that's basically how it works if the angle theta is acute. Now, suppose theta is more than 90 degrees. If theta is more than 90 degrees, well, then you have to use what is called a reference angle to find those ratios. Because we want to use an acute angle to find those ratios. So basically, you draw a vertical segment from the terminal side of that angle down to the x-axis, and that's going to form a right triangle. And notice that adjacent angle and reference angles, we've got a reference angle here, we've got a reference angle here in the third quadrant, we've got a reference angle here in the fourth quadrant. One of the sides of every reference angle is always the x-axis. It's always adjacent to the x-axis. You never have a reference angle adjacent to the y-axis. So those same 6 definitions of sine, cosine, tangent, cosecant, secant, and cotangent, those definitions still apply. Only now it's going to end up that the legs of the triangles have a sign, positive or negative. So let's get into that. If you're in the second quadrant, if theta is somewhere between 90 degrees and 180 degrees, then we create this reference angle, theta prime, and we still look at opposite over adjacent, but now adjacent is like an x-coordinate, and back here the x-coordinate is negative. So, and the opposite is a y-coordinate, and in the second quadrant the y-coordinate is positive. Now, since the hypotenuse is always Pythagorean theorem thing, square root of x squared plus y squared, the hypotenuse is always going to be positive. No matter where you are, no matter what quadrant you're in. Now, as a review though, in the first quadrant, I should have done this first perhaps, but in the first quadrant, x and y are both positive. X and y are both greater than 0. So all 6 ratios, sine, cosine, tangent, secant, cosecant, and cotangent, they're all positive in the first quadrant. In other words, if the angle is acute. You learn that in geometry. Actually, you don't learn about secant, cosecant, and cotangent in geometry usually. But now, so if the terminal side of the angle is in the second quadrant, then the sine of theta, well, sine, remember, is opposite over hypotenuse. Opposite over hypotenuse. Opposite's going to be positive because it's a y. Hypotenuse is going to be, hypotenuse is always positive, so we've got a positive over a positive. So the sine will be positive. H over oops. Opposite over hypotenuse. It's a positive over a positive. Cosine. Cosine is adjacent over hypotenuse. Well, the adjacent side is a negative value because this x-coordinate is negative. We're going backwards from the origin. So we've got a negative adjacent divided by positive hypotenuse always, so we get a negative cosine. The cosine is going to be less than 0 in the second quadrant. Now let's look at the third quadrant. In the third quadrant, the sine of theta, well, in the third quadrant here, I'm going to go green. Sine is going to be opposite over hypotenuse. Opposite over hypotenuse. Opposite is going to be negative because it's like a y value. Hypotenuse is always positive. So, and let's look at the adjacent also. The adjacent is also going to be negative because that's like a negative x. So we're going to the left. So x, the adjacent is negative and the opposite is negative. So, put some red here. So opposite, negative, divided by hypotenuse, positive. That's going to be negative, less than 0. Cosine, adjacent over hypotenuse. Again, we have a negative adjacent divided by a positive hypotenuse. Negative divided by positive is negative. Now look at the fourth quadrant. In the fourth quadrant, sine, let's see, this adjacent leg is going to be a positive because it's x. And this y, this opposite side is going to be negative because we think of it as y. So opposite over hypotenuse, opposite is negative. Hypotenuse is always positive. And then for the cosine, well, so negative divided by positive, negative. Adjacent divided by hypotenuse. The adjacent is positive. The hypotenuse is always positive. So the cosine is going to be positive in the fourth quadrant. So, a little summary here. Opposite is like a y. So the sine of theta is going to be positive whenever y is positive. Sine is always going to be positive when y is positive. So what two quadrants is y positive? The first and the fourth quadrants. We could do this real quick. Smaller. I'm giving away answers here, aren't I? Oh well. Now, but just as a reminder, we got in the first quadrant, we've got, oops, we've got positive x's and positive y's. In the second quadrant, we've got negative x's and positive y's. In the third quadrant, we've got negative x's and negative y's. And in the fourth quadrant, we've got positive x's and negative y's. So in the first two quadrants, since we think about sine as an opposite, sine's opposite over hypotenuse. So hypotenuse is always positive, so we only have to worry about the sign of the opposite. The opposite is a y, so sine is positive in the first and the second quadrants. Cosine is positive. Cosine is an adjacent guy. Cosine is based on the adjacent side. So cosine is positive whenever x is positive. And where's x positive? Oh, in the first quadrant and the fourth quadrant. So cosine is positive to the right of the y-axis. Sine is positive above the x-axis. Okay, and since I should have let that uncovered a little bit. Since reciprocals always have the same sign, if you're just taking the reciprocal or you're not changing the sign, you're just taking the reciprocal. So whenever sine is positive, cosecant will also be positive. Whenever cosine is positive, secant will also be positive, and vice versa for negative. Secant and cosine will always have the same sign, positive or negative, and so forth. And the same is true for tangent and cotangent. Um, so tangent, since tangent is opposite over adjacent, tangent's going to be positive when the opposite and the adjacent have the same sign. They're either both positive or both negative. So tangent will be positive in the first quadrant and the third quadrant. That's when tangent's positive, which would also be when cotangent is positive. And I believe that is all I have for this little trigonometry review.